So ionotropic receptors are one class of, postsynaptic or presynaptic receptor. And what they do is they allow for the opening of channels within their very structure to allow for ions to pass through. So they can open a sodium channel, right? And sodium can enter and depolarize the cell, for example, if this is located, like let's say on the postsynaptic membrane. They could open a potassium channel, and then potassium will leave, driven by largely the concentration gradient force. And you will get hyperpolarization, right? So it can actually result in inhibition, of the postsynaptic membrane. So what happens with an ionotropic receptor, and that's why ion is in the name, right, is that here it is in the membrane, and here's a neurotransmitter coming along, binding, and at the moment, before binding, it spans the phospholipid bilayer and the membrane, and there is no open pore or channel. But when the neurotransmitter binds, it swings open a pore, a channel, and allows for a specific ion to go through. And this can allow for rapid, depolarization. If it opens, for example, a sodium channel or a calcium channel, which would also, is a positive ion that would enter and depolarize the cell. It could also result in rapid inhibition, right? It could open a chloride channel, and chloride would enter, driven by the concentration gradient force, and hyperpolarize. Or potassium channel, right? It could open a potassium channel. Potassium would, go from the inside out because it's driven by its concentration gradient force. So the power of these ionotropic receptors is that they can result in rapid, fast inhibition or excitation of the cell, a rapid, depolarization or a rapid hyperpolarization. So every time you've got, a network of, connected neurons that involve, let's say, rapid excitation, like I'm going to, send a signal from my left frontal lobe down to move my arm this way. All of those synaptic connections involve ionotropic receptors. And I just want a quick word about terminology here, because these ionotropic receptors are also often referred to as ligand-gated channels. And that comes from the fact that ligand is a very, pricey word for a chemical. So the neurotransmitter, which is released from the presynaptic cell, right, is going to encounter, an ionotropic receptor. Let's say it's an excitatory, connection here, synapse here, so it'll open in response to the binding of that neurotransmitter, sodium channel that will allow for rapid depolarization. But because this is a neurotransmitter, is a ligand, and because this is a gated channel, right? Because it's before the neurotransmitter binds, the ionotropic receptors close like this. There's no open channel. But upon the binding of the ligand of the neurotransmitter, there's an open channel. So these are also known as ligand-gated channels. So a ligand-gated channel is the same thing as an ionotropic receptor. And this is a class of receptors that binds neurotransmitters and opens a hole, right? Opens a channel, opens a pore, and allows for rapid redistribution of ions across the membrane, which can result in rapid, inhibition or excitation of a cell.